Okay, so we're going to look at measuring potential difference. So if we look at this scenario where we've got a person lifting up ball bearings from A to B and then dropping them on B, and they're rolling down to C, and then they drop from C through a paddle wheel which spins the paddle wheel, and then when they get to D they roll back down to A. So we've got like a circuit of ball bearings. Okay, so a person continually lifts ball bearings from point A to point B. They roll along the top rail, fall from C to B, turn the paddle wheel, and then they roll from D to A along the lower rail. So, thinking back to your first year energy, when raised from A to B, the ball bearings gain, what energy do they gain? Gravitational potential. Gravitational potential energy when they're lifted up, which is supplied by the person. So the person is giving them that gravitational potential energy by lifting them up. When the ball bearings roll from C to D, most of the gravitational potential energy is converted into movements or kinetic energy, moves the paddle wheel. We say there's a difference in gravitational potential energy between point A and point B. In other words, there's a gravitational potential difference between points A and B. So you can see there's very little gravitational potential at A and quite a lot at B. There's also a very small amount of energy is converted into heat and sound as the ball bearings roll along the rails. So that's something that we've come across before, lifting things up, gravitational and kinetic energy. So consider now this electric circuit, which is similar to the one above. So the person in the mechanical circuit has been replaced by a cell, the paddle wheel by a lamp or a bulb, and the rails by wires. In place of the ball bearing, electric charges are moving around the circuit. So instead of gaining gravitational potential energy, the charges gain electrical potential energy in the cell between points A and B. The charges then travel around the circuit to the lamp, where the electrical potential energy is converted into, and we know this because we know that lamps convert electrical energy into light energy and heat energy. There's a difference in the electrical potential energy between parts A and B. In other words, there's an electrical potential difference exists between points A and B. The potential difference, or PD for short, is measured in volts. Potential difference, or PD, is sometimes given the name voltage, and we use them interchangeably. So the potential difference across a supply is the measure of the energy given to the electric charges which passes through the supply. The potential difference across a component, such as a lamp or a resistor, is a measure of the energy lost by the charges which pass through the component. Okay, so two definitions there for potential difference.